Yo, 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 what's up, everybody? Welcome back. Today we are working on writing a GPU driver for a Linux virtual PCI device. So, context here is we thought it would be fun to make a GPU. I'm not really going to go into the backing story as to why again. You know, it's just like someday in the future, I think it would be fun to make an FPGA GPU just because, it's fun. That's what we think is fun around here, okay? And in order to do that, I think that I want to kind of understand what a existing GPU does, or at the very least, what like the software stack expects a GPU to do, right? And so one way to explore that is by making our own virtualized GPU device ourselves. So what we're kind of working with right now is we have this like virtual machine called QEMU. Actually, it's QEMU. This is like an open source virtual machine. And so we have the ability in here to tack on our own stuff, right? So we are making a PCI device, a virtual PCI device, whose goal is going to be to write an image out to a file somewhere. Little smiley face .png. That's going to be his goal. And we're going to try to use like the Linux driver mechanism to do this, right? So we've had some success in the past. We wrote this like application to use the existing QEMU devices called VirtIO GPU. We've kind of had success in writing a application that talks like to this thing, right? So what happens here is like in the Linux kernel, you have like a driver that like talks to whatever one of these things, right? He talks to him, he talks to him, and he exposes a interface on dev dri. So if you like ls dev dri, you'll see like your GPUs at like card 0, card 1. And so what we do is in like our user space, we like open this file handle, and then we call some like ioctls on these file handles to get them to do some things. So we ask like, hey, what's the resolution of our output? And like, can we make a buffer that we can write into that matches that resolution? And could you please feed that buffer over to the monitor, please? Right? And so we've had success with that. And so what we're working on right now is we're trying to like basically take our existing app and make sure that it works for our custom PCI device. That's about the extent of it. We are on day 2 of this specific part of the task. So we have a GPU driver up and running. So if we go in here, and I think we can do like run our test app, and it does crash. But before it crashes, it does say, hey, we found a driver with Sphero GPU, and we found that he has one connector on him. Right, so that's kind of like the extent of what we've got so far. However, as soon as we try to inspect any details about that connector, our kernel crashes. And we kind of got to the point yesterday where we were trying to debug this thing, and we were struggling because we didn't have like any good debugging interface set up, which made this kind of difficult. But we have fixed that. And so now we can look at where this crash is. It's in DRM helper probe single connector modes. Right, so we can kind of go into this, or DRM helper probe single connector modes. I think that's where it was, or maybe it was in. I'll probably set a breakpoint in DRM mode connector. Okay. So I think we should be able to go run GDB, and what was it? It was a DRM. Oh, it was DRM mode validate driver. That's where we want a breakpoint. Okay. So let's set a breakpoint there and see if we can trigger this to give us a nice little breakpoint. I believe this worked. GDB-x run GDB, continue. Okay, and I go back into our virtual machine. And we run our app again. And now look at this. We've got a little breakpoint going, and we can like hit next a few times. And then he goes like, uh-oh, I'm a little angry. And you go, well, is there anything interesting about this particular line of code? And you can go like print dev mode config funcs. And he's like, null pointer. It's like, oh. So we're dereferencing a null pointer here. Hell yeah. So this is where we're at. We are trying to probe some information about a connector. Where connector, I guess I did not explain what this is. So the framework that is exposed to us as like dumb as bricks GPU device, i.e. no acceleration, just like draw me this buffer, please, is you have a CRT. I'm just going to delete this YouTube link because I don't know what it is and I'm not going to click it right now. So I apologize if that was something useful. It's just I don't want to, like, if it wasn't something good, then I wouldn't want that left there. So apologies. Normally I would click it and check, but I don't want to do that right now. So like you have like a CRT, right? He's connected by some wire to some like PCI device, right, in the back of your computer, your GPU, if you will. The connector kind of represents this thing, like is a wire plugged in. Then there is this concept of an encoder. Encoder? Oh, good. It was just the video of that wrestler saying you're dereferencing an null pointer. Oh, I see. The encoder kind of defines like what signal is going to go over this wire. Then like in like software, there's like CRTC, cathode ray tube controller, which kind of sets up parameters that this encoder is going to use in order to figure out what to send. And the CRTC is attached to some planes, which are attached to some buffers, kind of. So our user space API kind of has to like walk backwards to say like, okay, what are we connected to? What resolution is our monitor? What's his refresh rate? How often do we have to draw? Stuff like that. And then we walk backwards from there to go like, okay, so we are in like 1920 by 1080. Let's attach some buffers to that and like figure it. So we're starting at the end and working our way backwards up this back this stack. And I think we just kind of jump in and keep going. So I guess we'll kind of set this as a new section. We'll say this is fix get connectors crash. This is where we left off yesterday. And now we have our debugger. Should be very straightforward. So we're looking for DRM modes 1679. Okay. Let's open up a editor, I guess. And can we do cd source Linux? Okay, and then can we look for drmmodes.c? And it was 1679. Here we go. So we must have to set these functions somewhere, right? That's what we're looking for. And this gets called, okay, so we have our Sphero DRV. He is responsible for setting up everything, right? So he says, hey, I'm a PCI device. Could I maybe map some memory for my PCI device so that we can talk to it a little bit? Then could we create a DRM device, as in like GPU infrastructure device handle, please? And we are going to like initialize this thing and then maybe try to add a connector to this, who when you interact with this connector is going to call our like helper functions associated with that thing. And then we just register it. And so then when we get a bunch of like DRM subsystem ioctls here for free, and they are going to be interacting with our driver in some way that we haven't implemented correctly, right? So the suspect function here is this get modes function. We are supposed to be creating modes here, right? And so in this, where mode is kind of like resolution paired with refresh rate paired with whatever, right? Like something about like, am I high res, am I low res? What mode is my display in, right? Because you like connect like a cable to your monitor, right? And your monitor, when you go into like your like graphic settings, will support like 50 resolutions and like 4 refresh rates, right? So the mode is kind of like the kernel abstraction for that type of thing, I think. And we theoretically, as far as we understand, we implemented something. We're like, hey, we don't have any like monitor identification stuff, but could you just like add one at 1024 by 768? And then could you set that as preferred? And for some reason, if we do that, that's not doing what we need to do. So I want to see if we can figure out why. So I guess it makes sense to breakpoint here, right? That kind of makes sense. How do I want to do this? Let's just kind of see what is coming out of this. So we'll run gdb-x. We will rerun our virtual machine. Oopsies, source run gdb. All right, so he's continuing now. He's happy to keep going. We give him a sec to boot, and then once he boots, we run our test app. And that does now break here. And can we print count? What do we got here? 5. So we have 5 modes. Okay. So then we can just kind of start stepping through and see what happens. So probe add command line mode. So here we should have, oopsies, fuck. I want it to go back. So we are in update and validate. So I wanted to list here. Count is optimized out. Fuck, I wanted to look at that. I wanted to look at that and I fucked up. So can we just like reset the virtual machine? Let's just run GDB. I fucked up. And I'll admit it. I'll admit it. So we run our test again. Root, test app. Boom. Next, 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 next. Okay. Optimize out. Great. I guess I want like another window open to look at the source code, but I guess for now we'll just kind of move in here. So where this is, I believe, where the problem begins. So what we're looking for again, it was mode. We should have written it down. We should have written it down. It was in validate driver. It was this mode valid call. It was this mode valid call. So mode config funcs mode valid, which is not the mode, to be clear. To be clear. So we are looking for mode configs funcs or something. That's where the problem shows up. Are you calling DRM connector helper add somewhere? Yep. Right here. Right here. So fuck. Let's go. I guess we'll go back to. I should leave the fucking debugger open. That's the fucking mistake I'm making. So let's do this. Nix shell here. Nix shell. Give me a sec because I do need to reference it. My head can't keep all this state at the same time. Nix shell GDB as well, I guess. And then C build Linux GDB-X, and then we'll do this one more time. This is the last time, hopefully. Run. GDB-X. All right. So now we can at least look at the code. So we know that this is coming from, hello, my language server class. That's super cool. Super cool. Nothing's working. Everything's broken. Get modes. Okay. So this is called from probe helper. And then down here, this gives, we get into update and validate here. Okay. And then in here, it was like, I already lost it. You know what? We'll let the debugger tell us. If only there was some way for us to write stuff down. If only. Okay, it was in here. Right. Okay. Okay. So here is our backtrace, and we should not forget this. This is the important piece here. So let's just leave this open. We'll leave this open. So single connector modes, update and validate, DR mode validate driver, which is here. And then this is a problem. So dev mode config is different than the mode we're getting, right? So we're supposed to call mode config mode valid on this thing, and we're just not doing that. So if we look at our virt.io GPU example here, does he set this? He calls mode config init, which we probably are just not doing. I don't think I've called this anywhere. And this guy probably sets the functions. I'm actually not sure. Oh, here, virt.io GPU sets them as his own thing here. Okay. which has like a frame buffer create call, which is kind of interesting. I don't think we need that. Really, the only thing that we need right now is mode valid. Mode valid is the important one here. And what's weird here is he doesn't actually set mode valid here. Right? Mode valid here is completely unset, which means that somebody else must populate them. Must populate him, probably on config init. Probably here. So maybe standard properties. This is all prop. Okay. But maybe in here somewhere they set the function pointer. I guess we could look for, I guess funcs here was completely nulled out. Right? Am I high? Our funcs was a null pointer. Oh, so he defines funcs here. He defines funcs here, which now is not null, and then they check for if mode valid is present, right? Here they are calling funcs mode valid. So this is the piece we're missing. This is the piece we're missing. Is this assignment here. And I suspect that we didn't call this as well, which seems important now that I'm seeing it. So let's kind of run into our driver and try to get this running. So they do this before the connector in it. Looks like they kind of do it like here. So let's kind of try to do the important things. And figure out what to do next. Okay, so this, I believe, is the right type. DRM device, okay. And then prefer host byte order. I think that we're not going to really worry too much about this. Modes will be validated against the frame buffer size, so I think that we also might just not support this. Frame buffer modifier is not supported. I mean, the thing is, we don't really know what's happening, right? So we might as well just do nothing. You already did it on line 97? Oh yeah, we did. Look at us go. So we did initialize it, we just didn't set our functions. Good eye. Good eye. I just forgot and I didn't use my eyes. So really the only thing that we're missing is sphero derv mode funcs. And we are going to have to do something similar to what they're doing, presumably. I guess we can start by just having nothing. Right? That's not too crazy. As long as it can point somewhere, then they can check that this will be null. Right? So we can just kind of do this. We can just do this and see what happens. That sounds kind of fun to me. Sounds fun to me. So he's mad because sphero derv mode funcs undeclared. Didn't we just declare it? We did write vert IOGP here. It's a really good point. It's a really good point. He's a little angry. Reasonably. Sphero derv mode func, is what we called it? Yeah, alright. I don't know, man. We will see. The linking here takes a long time. I think link time went up when I turned on debug info, which kind of sucks. I think this build takes around 30 seconds, which is a lot less than a lot, but a lot more than nothing. It's kind of in this middle point of like, it's painful, but not super, super painful. I was looking into like increasing the compilation speed a little bit, and I just like couldn't really find anything that reliable in my brief look. So let's edit our run script now. We're not going to set any breakpoints, but we're also going to run through GDB. I think that's kind of nice, just in case something goes wrong. Okay. And then hopefully we get a little farther. So he does still crash, but he crashes in a different spot now, which is super cool for us. And if we call this again, I think that typically what we've seen here is, yeah, the second one just like kind of, our kernel's like in a bad state at this point, so we can't just rerun and set a breakpoint, but we can see where this fails. This is in DRM mode object get properties, and we can just kind of breakpoint there. So break DRM mode object our DRM mode object get properties. And we'll just see where that goes. You could compile the tree as an out of driver as an out of tree module. Yeah, but then I'd have to like get it into the sysroot. I did consider that, but then I didn't really want to deal with like .ko loading and unloading. But maybe that would have been better. Okay, so can we just like kind of step around until we see something that crashes? Step, 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 step. Nothing in here seems like a problem, actually. Oh, that's annoying. So if I hit continue here, he's not happy. Fuck. I wish, so when I tried breakpointing on die before, it didn't really work good, right? If we do like, break die, I think our backtrace just gets kind of like fucked up, unfortunately. Which would have been the nicest way to do this, because then I could just go like, tell me when you crash. Test app. Oh, see, here we're in die, but we don't really get anywhere fun here because we're in like a page fault handler, which is kind of annoying. So maybe we can compare this with us. Page fault, oops. Here. I guess we could look for search x stable. X page fault here. ASM X page fault. That's here. Yeah, so unfortunately we're like not really too lucky here. Although we did see before that when we just kind of tried to step next within something, we saw something. We saw yeah, maybe we'll breakpoint in get connector and then try to finish get connector and see what happens. Because I think we did see some success that way before. DRM mode get connector. And if this doesn't work, we're gonna have to be a little bit more methodical. But, you know, whatever. You could do some init script you could write an init script to do some of that stuff. I don't remember if I already answered this, but I was then thinking about like, well, then I have to like get the kernel object into the rootfs over and over again, and that doesn't seem like it would be super trivial either. But, hey, Ron, can I just like finish here, and then will it figure it out? Okay, weird. Finish. Yeah, so unfortunately just typing finish here, he's not correctly identifying when like signals are thrown, which is a little annoying. Okay, so maybe we look at the actual source code here. DRM mode get connector. And we know that he's crashing in some get properties call. Okay. And so here we can probably take a guess. Well, we'll see. So here he iterates how many properties we're looking for. So we're looking for some amount of properties from this thing. So we're looking through some list of property IDs. Okay. And presumably one of these property IDs is not set. So probably what makes sense here is for us to breakpoint here. And maybe we try to like log each what properties we're trying to get or something right in here. Right, we do something like this. Although this is wrong. His prop is a DRM property. So I guess I more want this. I want like Array of pointers to GRM property. So I guess I is the interesting value here. No, he's iterating over all properties in the object. And if, what is count here? Count is how many we have found, I guess. Right, so count is the index into prop pointer. And he's trying to put the... Oh, he's like getting every single value until we find them all, huh? He's calling get value. What is val here? Val. Oh, I'm missing something. QEMU allows you to pass an int ramfs from a directory, so you could put the KO and init script in there. Oh, that's pretty true. That's pretty true. That makes a lot of sense. Okay, so here they're trying to get all prop values. Is prop values an output? Maybe it is. Maybe that's why I'm confused. Props pointer and prop values. So this is an array of property IDs. And is this an output? Ah, I see. So they are, this is not give me some object properties that I'm asking for. This is give me all object properties that you have. So we're iterating over every single one of our object properties, and one of them is we are not able to get it. I see. So do we use atomic mode set? We have driver atomic. And we have mode config funcs, but I don't know if we have atomic commit here. I don't think we have that. So, right, we don't have jack shit. Right. So that means that he thinks that we don't have this, and so he's trying to just call into this way. And this is just kind of dereferencing obj properties. Which with count. So presumably this count value is like not correctly initialized. That's kind of my guess here. He thinks you have a atomic because of the flag. Yes, but we don't have the function pointer. Right, so he calls, I got lost here somewhere. It was, he calls, oh, this or that. My bad, I misread. You're right. I thought this was an and. This is an or. So if we have driver atomic or these things are true. So he thinks we do have atomic. And our property flags is not immutable. Is mutable and not immutable. Read-only properties bypass atomic mechanism and they store their values in these mostly devoid. Okay. So what is this opt? Where does this come from? I guess maybe we just breakpoint here. And just try to see, maybe we print out something of interest here. So this is obj, he's writing to property. Property is the output, I think. No, val's the output. He's looking for if any of our pointers match the pointer that they're getting. Weird, okay. And then if they are, he gets the value. I see. Okay. I think I understand. And so our thing to look at is if obj properties is like sane. That's the thing we're trying to investigate. Okay. So can we then run it again? GDB-x run GDB. serial root test app. Okay. So we don't want del1. We don't want this breakpoint, actually. We just care about this one. We didn't build. That's true. Which is annoying. But I guess also that prop thing that we added was not valid. So I guess we just want to write like this. And then it should be fine again. It's just our breakpoint is now probably in the wrong spot. Which is where we were. Okay, fuck. ron.sh. One more time. One more time. Root test app. Okay. del1, continue. There we go. So can we print obj here? And what we're trying to decide, we're just trying to decide if obj values is fucked up, right? Because in here, this is what we're expecting to see. Obj, and it's like obj properties. I guess it's count was what we're looking for. So he thinks we have 5 properties with count. And we want to see values 0, 1, 2, 3, 4. So this is all fine. This is all fine. So probably it's in the other path here, right? We're probably in the case where he thinks that we're atomic, and he's trying to call the atomic callback, which is not set. Right? We're probably in here. So this is my guess. Because otherwise, everything was fine. But we could probably check. We could breakpoint here, as well as in here, and just see which one is failing. So this is atomic get property, which immediately crashes. Yeah. So we're in the atomic path. The atomic path. So here we can start adding like some logs, I guess. Presumably we're in the connector path actually, because we have not done anything but asked for connector, so we can probably assume that that is the case. And okay, so how does this work? They're saying if property is this, else if property is that, else if property is that. Okay. I guess we just want a breakpoint here. So we want like B here. And then we'll see where it ends up. I guess. This is a really slow test loop, but this is a lot faster than if we didn't have GDB. I'll say that much. I will say that much. Okay, test app, we breakpoint, and then we just start hitting next and see what happens. Ah, there we go. There we go. So it's at 8:06. This guy, he's dereferencing state CRTC would be my guess is the problem. Right, so we got up, down, up, backtrace. Fuck. We cannot not backtrace here, but we know that it's at this line. So we're gonna one more time. What an inefficient way to do this, but well, it's fine. It's fine. It would be nice if we could backtrace through the exception handler, and I'm sure there's probably a way to do it. I just don't know how. But that's okay. Test app. Okay, let's print state. State is a problem. So we are at line 8:06. And so he's assuming that if we are in DPMS property, that state is valid. So what does state come from? State comes from DRM connector state. Okay. So this, hold on. This is an argument to DRM atomic connector get property. Oh, here. So state comes from connector state here, where connectors are DRM connector. So I would bet here that when we create our connector and initialize him here, we must never initialize his state. Right? Like in here. Can we see like where it's assigned in the other variants here? This doesn't look like anything like what I'm looking for. I guess we want to look at like, maybe we look at the vert IO GPU driver and see if it was under vert IO GPU display. Here, somewhere they must, like when they handle their connectors, somewhere. Do they like assign state anywhere in here? No. Although I guess they have atomic duplicate state as something that they've implemented here that we didn't do. Right, so in here they allocate a new state and they copy the state in. So presumably if we don't do this, we don't have connector state. So I'm kind of curious to see if we implement these two functions, if they fix our problem. It also could come through a reset. That's also very likely, actually. Very likely. When they call reset here, they initialize the state as well. So I think probably all three of reset, duplicate, and destroy sound like something that we should be implementing. And it also looks like they didn't do anything special to make that work. Oh wait, we do have that. I'm high. I'm high. Although they manually call reset and we don't, I think. I think I saw that somewhere. In there, where were we? Vert IO display. They do call mode config reset, which calls reset on each of the connector functions. And we don't do that. So let's kind of like huck a reset on ours and just kind of see if that changes anything. Let's just see. You never know. You never know. I guess we'll call this crash. We'll rename this to crash is. There's more than one. It's a hard life out here. And part of me feels like maybe there are some docs that I should have read. I don't know if this is like the wrong way to work, but it is the way we are working. So even if it's wrong, we will survive. Okay, run. And then gdb-x, continue, and let's just see what happens. Give it a sec. Nice, root test app. Oh, we're so back. We are so back. Okay. Sick. So now we no longer crash. Look at us go. And let's try to see now, I guess, if get connectors sane, question mark? Is it sane? Hello, driver time? Yeah, driver time. I apologize, Mlug. This is not Zig. and I'm sure you will be disappointed in me for that, but we have enough problems without trying to shoehorn Zig into the kernel. Okay, so in our little test app, I guess our test app is written in Zig though. That's a big win. Where do we want to edit that thing? I guess here. I guess I didn't want to do it here, actually. Oh well, but we've already made the mistake. Okay, so in our test app, we said I would like to print our first connected connector. And we might be returning no connector here. I guess I'm not really sure. But we should have a connector that is connected. We should. So maybe we will write down here got connector and got resources so that my poor little brain can understand what I'm looking at. And I guess we will run. I think we can turn off GDB now. We don't need it anymore. And we can run this in the background so that we can go into our test app and set up SFTP again. So IP link udhcpc-i enp03. Okay. Then we can run zig build and SCP that shit over and run it. And we see that we got connector, DRM connector. Nice. We have a connector. Now, what are we supposed to do next? We are supposed to get our preferred mode from the connector. Who knows? Maybe that'll just work. I don't know. We have to implement. I guess he didn't crash. Unless, yeah, nothing crazy in there. But we should probably print out what we got here, huh? So we'll say, got preferred mode. Okay. So we do get a preferred mode that has a 1024 by 768 display who has a name. I wonder what his name is. Can we print the name? I just want to see what it is. You never know. Whose name is 1024 by 768. That's a good name. And then we can try to create a dumb buffer. Surely this won't work, right? This is where we're going to fall over. So here we are hopefully moving into, we should be moving into buffer allocation stuff now. That's kind of like the next thing, which we've been doing. We did a bunch of reading on, kind of in happy hour. So we should understand it a little bit. So I guess here we're on buffer allocation. This is 4310. Okay, so surely this won't work. This is probably just going to be like, yo, bitch, shut the fuck up. Yeah, error create dumb buffer, which is a reasonable thing for him to say because we haven't implemented it. So my understanding is that in the driver, we are going to end up in drm.ioctl.c, and he's going to have this create dumb ioctl called. Create dumb. And this is just going to go into our driver and call dumb create. Wow. Which we have not implemented. But someone else has. So vert.io dumb create has in fact done this. And so in the reading that we were doing in happy hour, it looks like there is this thing called GEM, Graphics Execution Manager. And he is supposed to essentially handle like common operations related to synchronization of memory between a GPU and CPU, right? So you kind of have like, RAM, right? Wow, RAM, the stuff we like to download, right? You have your CPU, and he talks to the RAM, but your GPU also talks to the RAM. So far, so good. Except RAM, slow as fuck, right? RAM is very, very slow. And so CPU has caching in here. And you usually draw these as like a period because you have like L1, L2, L3 or something. And the RAM gets like copied into here, right? for the CPU to do like actual work, because it's just like way fucking faster if he works with the stuff that's close by instead of the stuff that's far away, right? Chill. But that means that if I'm writing like a little smiley face into my my L2 cache here, and then the GPU tries to get it, the GPU's like, uh-oh, I don't see that anywhere, because we didn't actually write that to RAM yet. So gem is like kind of like partially a way to kind of like coordinate this stuff, as well as like a way to give like kind of a user space API to things that might be GPU buffers, right? So they have like gem handles, gem handle, and these, like, the gem system kind of handles the fact that like your memory might be here, or it might be here, or it might be over here, right? Your gem handle doesn't really care about that externally. He's just kind of like, oh, I have this thing, and like, where is it? Like, I don't care. Like, I'll write to it wherever it is. That's kind of like my basic understanding of it. And so I believe that what they do in the vert.io version of this is when they create a buffer, they just ask the gem system to create it for them, essentially. I mean, they also have like extra information about this thing. So when they have like a gem, I think that they wrap it with a vert.io GPU object, which has the gem object inside, but he also has a bunch of like other stuff that he might care about. Now we might get lucky in that we don't actually have to care about these things. I think that we might not have to at this point. So I think that we're going to try using a raw gem handle and see how it happens. What's kind of fun here is they call this gem shmem create. Durham gem shmem create, right? And shmem from our happy hour reading seems to be basically the same shit. The Derv gem shmem is the shmame schmidt as dev shmem. So if we do like a mount grep shm, this is like a tempfs file system, right? And so like what this is like a file system view into just like your physical memory, or your virtual memory, I guess. I don't know, memory. Well, we won't define what type of memory. And so if I write a like 100 meg file into this folder, it's like, oh, that's just 100 megs of RAM that I can't get back, right? But what's nice is that if you this is like a file system now, right? A file system view into your RAM, which means that you can use all of the same tools that you normally would to interact with files and use them in memory. So if you want to make like shared memory, you can just like put a file in that folder and then like send it to someone else and be like, hey, go look at that file. And then you've got like shared RAM. Fucking sick. And so what's even funnier here is that if we are sharing RAM with the GPU, they actually just use the same subsystem. And we found in here that like one of the things that happens in here is they call shmem file setup with a file called drm object. And this just creates an unlinked file living in tempfs. And so like this creates a file named drm object, like kind of like immediately deletes it, kind of. And then you will see like a name in proc PID maps for that thing. It's kind of funny. But I kind of think that all we have to do is make one of these. Now, I haven't looked at this at all. This looks scary, right? A lot of like operations that are related to this shared memory. I don't know what those are yet. But if we're just trying to like create something, okay, I mean, if we look at these all look like nothing that we have implemented in, nothing that's been implemented in our specific driver. In fact, this is not driver specific code at all. I wasn't paying attention. I was in the wrong folder. So in vert.io GPU, we probably just have to call this. And then we will have a shmem object. Now, does this guy handle the ID? Right, so when somebody calls GPU object create, we have to return that handle somewhere. Because in our application, we call create dump buffer, and he comes back with an ID. So where does this ID come from is like an important piece of the puzzle that we need to solve before implementing. So in the vert.io version, what do they get here? So presumably this handle is going to go into this location, right? So we call this function with these arguments, then handle has to get populated somehow. So can we look for handle? Here, handle is the output argument of gem create. Okay, so who assigns this? Handle comes from handle, which comes from DRM gem handle create. Got it. Got it. So this attaches a gem object to a handle. And then I think I remember reading something about how the handle ends up, like, if when we call this, this thing is like reference counted, this gem object. And so we like create the object, and then we say, okay, we're fucking done with it. We're done with that guy, but this handle keeps a reference to it. Hand wavy. So I think all we have to do is implement this. Yeah, sure. So let's go into. Okay, so we need to write down these steps. This is important. So let's go into sphero.derv and look for DOM create. I think it's in here. Boom. Sphero GPU DOM create. I kind of like leaving the B off DOM as like a really stupid. But that's going to be a problem for grepping later, so we're not going to do that. But it would be funny. Okay, so now we need to implement this thing, which means that we should copy the function signature. And maybe we should even read what it says it's to do. Maybe, instead of just guessing. So this creates a new dumb buffer in the driver's backing storage, gem, TTM, or something else, who cares, and returns the resulting buffer handle. This handle then can be wrapped up in a frame buffer mode set object. Note that UseSpace is allowed to use such objects for render acceleration. Drivers must create their own private octals for such a use case. Width, height, and depth are specified in the create dump argument. The callback needs to fill the handle, pitch, and size for the created buffer. Okay, yeah, simple. There's nothing crazy there. Really nothing crazy. So we'll call this Sphero, I forgot, GPU. Don't create. And what did we say we have to do? We have to DRM gem handle create. This goes into args handle. We need to DRM gem object release our version of our object, and then we have to call, what was it? DRM gem shmem create. I think it's literally just this. Okay, so this is dev, right? Our DRM device comes in already. Params here, they're a little mad, but they populated some stuff here that we probably don't really care about. We can figure out the size from this directly. So our size is going to be width times height times bits per pixel. Sure. Who defines if we support that thing though? So in their version, they must figure out they just write 4. Oh, I see. They just check if it's 32. I'm okay with doing the same thing. GPU driver? What GPU? We are running a GPU driver for a virtual PCI device that we get to implement. So, it's kind of like not well defined. Not well defined, which makes it easier for us. So I'm okay with doing the same check. If this is not 32, we'll just say no. If they can do it, we can do it. Then we create our shmem object. And then, sorry, so when they did this, they create the object and then they just release the object. I think. I don't think there's anything else crazy in here. Shmem object. They have like resource IDs for tracking with the other side, but otherwise it's just called DRM gem shmem free, which I guess is different than gem object release. This must call free if it needs to. Private object finny free mmap offset vma remove. Nothing in here seems like a free, which is a little confusing to me. Oh, that's release. Release and put are different. Oh, that's confusing. Drop a gem off reference, and this just calls object put under the hood. Okay, which calls object free if he needs to. Okay, so that seems reasonable to me. That seems reasonable to me. So then I'm more confused about gem object release, which is release gem buffer object resources. This is the inverse of init. So I don't understand why this would be any different. Why we need this special case for release? Release is only if error occurs. Yeah, but like in my mind, I don't see why it matters if an error occurs. Oh, I guess because no, right? Because like here they create the thing, and then here they try to create like a handle to it, and if that fails, shouldn't like the reference counting kind of behave the same? In my mind, it should. In my mind, it should. Okay, so it seems like there's probably also, they're saying that the release is the inverse of init. So in here, they probably call init on this thing as well. Right, how do we attach, what does this return? What does this return? DRM gem shmem object. DRM gem shmem, which has a gem object. I see. Okay, sure. So this is defined in DRM gem shmem helper. Okay. And we don't have a size here, so we'll just say u int 64t size is equal to args width times args height times 4. Okay. Okay. This must return, this is a struct dev gem shmem obj. Like this, I think it was. Shmem object. Okay. And then we have like, I think we don't care about like resource ID getting or anything. Did we have basically just this part, the handle creation. So DRM gem shmem, or DRM gem handle create, which takes it a file, struct DRM file, which we have here, as well as, oopsies, what else does he want? He wants the DRM gem object. So this is shmem obj base pointer. And then he has handle pointer, as in the output. So handle pointer is a unsigned int. Oh, U32, sorry. I guess that kind of makes it sound like we should use U64 here. If we're using U32 here. Okay. This is incomplete definition of this structure. So this is defined in drm gem shmem helper.h. Yeah, so I don't know why he thinks that it's incomplete. Should be fine. I don't see a problem there. Does it work? If the handle allocation fails, you need to free the gem shmem object, the shmem gem object. But I don't understand why, like, that object would have to get freed either way, right? right? Like if we are using the reference counted versions, wouldn't that also need to free it later? That would be my understanding, but I mean, who fucking knows? Okay, so incompatible pointer type. Oh. Struct derm gem mem object. Wait, why is that incompatible? What the fuck? Am I high? This returns that, right? Am I stupid? Oh, dev to DRM. Thank you. Thank you. That explains a lot, actually. So now we have to check if this is pointer error, surely, right? This thing can fail. Yeah. So we will do I think we're doing a typical like return RC here. So here we'll say like int RC is equal to 0. And then we'll say if this is an error, RC is equal to pointer error mem obj, and then go to like this. Okay. Now, in this case, we are going to have to free something, right? We're going to have to free this thing. They're saying that we should call I'm still not 100% convinced on this release. I kind of want to just do this. To be honest, you know, I could be wrong here, but member reference is this wants a DRM gem object. Oh, he wants this probably. Yeah, there we go. My K key keeps falling off. That's kind of funny. Okay. And I'll write like fix me. Do we really need to call object release? At this point, there's only one reference, so it's pointless to decrement the ref count. Only if something like the reference, like it's pointless in that I could just call release, but it's not pointless in that I don't want to deal with multiple code paths. And I guess really this isn't error, this is just red. And you don't have to free it if it's failed to create. That's a good point, actually. That's a good point. It's really just more here if this fails. We'll say if RC is not equal to 0. I guess even here, it's fine. Like we can just fall through. Yeah, I think that this actually just kind of works out. So we'll just put a note here. Both error and non-error path have to release their reference to the created object. The handle owns it now. If the handle failed to create, then the object should get freed anyways. And then we'll say, I think. I don't actually know. Well, that's the theory at least. Why isn't this like, this isn't like fucking auto formatting like normal? It's annoying. But otherwise, this seems reasonable to me, right? We just create a shared memory object that is now registered with the gem subsystem. I guess we need to put this actually into args handle. We can just kind of like shove it directly in there. GQQ. Yeah, it's not working. I do GQ all the time like this. And it's not, I don't know. It's not auto formatting. I don't know. I use that all the time. I like how you can just type GQQ in the chat and it looks like you're like mentally challenged. Like you're just like struggling. You've just like put your face on your keyboard. But it's actually just that it's Vim words, and we all know what you mean actually, which is crazy. All right. So I think maybe this is enough. Maybe. We'll see. Dun, 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 dun. I like how long it takes to write like a 5-line function when you have to ramp up on like all the context behind it. This is why like I find writing code from scratch, you move so fast, and writing code where you have to understand all of the implications of every function you write is really slow. And I find it like incredible that like new developers can like learn to write JavaScript and React. I'm like, dude, do you know how long it would take me to write like any fucking function? Like, you know how much context you need to be able to do that? That's crazy. That's crazy talk. Okay, so let's restart our virtual machine. And we will try to run our little app. SCP. We do need to turn on networking. Okay, we're chilling. And it looks like nobody crashed, which kind of indicates that we got the dumb buffer. Right, because we return here. So it looks like this succeeded. Now, we don't really know if we did anything sane, but we do know that it didn't crash. He at least didn't tell us he errored. So that's a great sign for us. And let's go on to add frame buffer. 010658. We'll call this make a frame buffer. So you might be like, didn't we just create a buffer? My understanding is that a frame buffer is like, I think dumb buffer is like essentially just like memory, and a frame buffer is like memory plus like metadata, i.e. HDisplay, VDisplay, pitch. Oh, we forgot to set pitch and size, huh? It did say that we have to set those things, and we just didn't do it. So width, height, and depth are specified in create dumb argument. The callback needs to be able to handle pitch and size. So we need to do that. We do need to do that. I swear the big faux XXXXX, I swear I thought of that independently, but it might not look like I did. Okay. So args size is equal to, I guess we kind of just calculate this here, right? And pitch is equal to args width times 4. So we can kind of do it this way, where we have pitch times height is the total size. And then everything else comes for free, right? Pitch, size. Cool. So what was I saying? Yeah, you might ask why is there a frame buffer and a dumb buffer? And it's because the frame buffer, I think, can be like, it can connect to multiple types of backing buffers and like has some like extra metadata about it, something like that. I don't really know. What a frame buffer does, to be honest. But we can look at what they do. We can look at what, if we call DRM ioctl, it's add FB. He calls basically into add FB2. And let's see, like, what does a driver do? It's probably here, DRM internal frame buffer create. It kind of feels like there's no, oh, here we go, FB create. This is the interesting piece here. Okay, so this is specified as vert IO GPU funcs. So I don't remember if we did this. I think we nulled out this function in our version, I think. So we had mode funcs. Yeah, so here we are going to have to implement FB create is equal to Sphero GPU frame buffer create. Okay. which has this API. And we don't know what to do here yet. Let's see what they do and kind of work backwards. So they check the pixel format, they validate that it's one that we support. Pretty reasonable. They find the actual GPU. Okay, don't be fucking annoying. Don't spam what are you doing __ question mark like a million times. I'm just gonna ban you because it's like fucking annoying. Dude, can you, like, if you were like in fucking real life and somebody was like giving a presentation, can you imagine like just spamming them? Just like, what are you doing? What are you doing? What are you doing? What are you doing? Shut the fuck up. Shut the fuck up. Like, it's not about you. Okay. So we look up the handle for the object that we gave back to user space. We gave them a gem handle. I actually thought you filled them and just want to see them printed in user space. That's pretty reasonable. That's pretty reasonable. We should print those things. And I will maybe in a minute. Then what does he do here? He says vert.io GPU FB. So he has his own kind of internal frame buffer thing that kind of has a fence associated with them, where I assume a fence is kind of like like some sort of synchronization primitive, I would assume. Right? Like when you see like atomic fence, that means like that like all like you have like consistency between like everything that happened before that thing will happen before the fence, and everything that happens after the fence should happen after the fence. So I assume that this is like a similar concept here, but for like communication with the GPU. So I'm going to assume that we don't need to worry about that right now. I think so. They're using like a vert.io command queue to like send things over from like guest machine to host machine. I think we can probably get away with like like just writing some registers that say, here is our frame buffer size, here is where it is located in memory. I think that we can get away with that instead of trying to use some sort of complex queuing. And we can just say that as soon as we write that, then it's valid. Sounds reasonable to me. Sounds reasonable to me. So he looks up the object. That's the important part, because this is how you actually get the memory out. Oh, interesting. So we have to remember that after we look this thing up, we have to free our reference. The good old Google search for metal fence while doing all graphics on Mac, and it's all pictures of actual fences. Dude, the worst one I had was at work one time. I Google searched C strings because I just wanted to know, like, you know, what are operations? We have like strlen, strcomp, like what are our C string operators? And I searched it in Google Images, and it turns out that C strings are kind of like a skimpier G string. And I sat like, we had like open office, and I was like a co-op, and I sat, or like an intern, and I sat like at the front, so everybody behind me could see my monitor, and I was like panicking. I was like, fuck. I just like try to like look up like technical concept and just get like a page full of ass, and I'm like, no, that's not what I want. No, I want. Make it stop. Anyways. And then they call framebuffer init. So, which means that they have a DRM helper to fill a framebuffer struct. Oh, okay. So there's like a DRM concept of a framebuffer as well that we need to probably initialize. So probably in there, like, oh yeah, it's just this. So then they call DRM framebuffer init. I wonder why. Oh, I guess because the framebuffer is part of this API, right? So this is this. Not guitar strings. I wish getting guitar strings would have been fine. Okay, so I guess we can kind of just do this somewhere. And then we also do this, where we try to look up our object. Then we have to, at the end of this, we're going to say unconditionally, we are going to DRM gem object put and return RC. Except we can't return RC here. We need to return the frame buffer, actually. So we return null on failure or error pointer, I guess is kind of more correct. So we say if RC is less than 0, we return error pointer of RC. Okay. Seems reasonable. Okay. And is there anything else that we really have to do here? I'm not really sure here. Struct DRM object star is equal to this. We need access to this function, so we ask Clang to tell us where it lives. We also ask Clang to tell us where this lives. Okay. Now, this stuff, this is our DRM device here, I think. So, right, he wants a DRM frame buffer. Oh. Which we don't have yet. So I guess we just make that thing? Because here he, I think, just called kzalloc and then immediately called init. So we can just say, this kind of indicates that we have to hold on to this thing somehow, right? Where does his frame buffer go? Right, he kind of kzallocs this thing. And then kind of just does nothing with it. Like, he doesn't return it. Which kind of means that here, the FB functions that he passes in must have a destroy. Nice. So we are going to need some sort of handles to implement for this thing. Okay. And we are going to use the default create, default destroy. All of these are defaults, actually. So how does he ever free this memory? This has to get freed somehow. I just googled C strings. It's mostly images explaining actual C string pointers. Damn, maybe like 10 years ago it was like more of a problem. Or maybe I did something even stupider. Maybe I typed C strings are ass. Or something. Yeah, so I don't understand how this structure ever gets freed, right? Someone must do a container of on the frame buffer to extract the parent pointer back. I just don't understand where that is. Right, I would think it has to be in here, but these are like generic functions. Helper, 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 yes, these aren't implemented by here. So how do we, I mean, we could look for container of vert IO GPU frame. Like, it has to be. Right? We know this has to be used. To vert IO GPU GPU resource flush. Prepare FB. Clean up FB. Even this isn't it. So who fucking frees this memory ever? K free VGFB? No, like there's something missing here. I mean, it could be a bug, or maybe it's just not really important. But it seems crazy to me that they just never free this thing. Right? I would think that it would be here. Right? I would think that you were supposed to wrap destroy with your version that like frees your memory. I can't see where else you would do it. I can't see where else you would do it. So I suspect that there's a problem in their driver, or we haven't found it. Those are the two options. I think it's also personalized search. C string brings up ass for me. Your personalized search is all about ass. What the fuck just happened? There we go. It seems confused. But we'll get there. So it's Pharaoh DRV. I don't understand what's going on here, where it thinks dirty FB is CRTC reset. Yeah, I don't know what's going on there. This comes from DRM damage helper. It must just be confused. There we go. There we go. Yeah, I'm pretty lost there. I mean, what I want to do is I kind of want to just have, like, our frame buffer in here, to be honest. I kind of want to do it that way. And then we can say, like, bool. Can we, like, check if this is initialized in some way? FB, bool, FB init. Like, this is just kind of what I feel like I want to do. But I don't know. I guess there's no way to get back to our device handle here, huh? I guess here we get dev private set to Sphero dev. And then in here, we can say that our driver is dev private, which means that here we can check if priv fb initialized, return error pointer. Like, we need some way to flag, like, already initialized, right? We're kind of saying that we only support one frame buffer. I guess the DRM frame buffer is the first field of vert IO GPU frame buffer, so the pointer values are the same, so you can just pass the DRM frame buffer pointer to kfree. Oh, dude, that's so fucked. But that's probably what's happening, huh? Dude. That's fucked up. Okay. I see. In which case, I guess we could do it that way too. Was there even anything? Why did we have extra data that we needed to associate with this thing even? I don't even remember. I kind of feel like there might not have been. Oh, here they're trying to fill up this DRM frame buffer. So I guess we could try doing it that way and see what happens. So what did they do again? Vert IO GPU display or something. So I guess we just want to allocate our, like, the raw frame buffer. Like this. Then here we just, immediately use that thing. And we initialize this. Presumably, if something fails here, then we have to free it. I guess. Is this the function? I guess we just call k free fb. I guess. I don't know, something like this. Something like this. DRM, gem, object lookup returns a, DRM gem object. Oops. And don't we have to associate this thing somehow? We missed that part. Where does their... Oh, it's not here, I guess. It's obj here. Oh, it's got into the frame buffer in it. Oh, and then they set obj 0 to obj. Okay, I see. So this is FB obj 0 to obj. Okay. 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 And I guess we will no longer do this priv shit. We'll just kind of let the frame buffer kind of fly around. And this presumably can fail, right? Returns a reference to the object name by handle if such exists, null otherwise. So if not obj, turn error pointer e inval or something. I don't know. Is it negative here? I can't remember. Yeah, it is. Okay. Then here if RC is equal to error, I guess there's only one error thing, so can we just go k free and then go to out or something? That's fine. That's fine. I'm fine with it this way. Return RC? No. We return the frame buffer. Yeah, sure. I guess we do this. No, because we need to call this either way. Sure. Okay, whatever. That's fine. It feels fine to me. I don't know. This isn't like my happiest function, but it exists. Yeah, I don't know. Then do we actually hook this up anywhere? We should call framebuffer create on something, which goes into mode funcs, which we did use here. So it feels like mostly fine, probably. I think there's like a potential chance that this works. So let's log here. Created buffer pitch ID and size. Pitch ID db ID size. Okay. And then here we will say got frame buffer with ID this. All right. What is this 24 in here for? I feel like we didn't use that anywhere. I feel like in the vert.io version, they validated like the format of the frame buffer, which we should probably do. We should probably check that it's RGB something, 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 something. But, you know, fuck it. So we expect this to work, which means that we can move on to here. Stood debug print got encoder and print it. Right, let's just kind of see. And it's crazy that my VM Linux is still fucking linking. That's kind of funny. And then I think I noticed that these prints in here didn't have new lines, which is annoying. So let's fix that as well while we're here. While we are here. So when we add the frame buffer, I don't think we have to actually ship that shit over to the other side yet. I think that we save that for when we actually like try to commit the buffer somehow. I think. I don't think it like I think host doesn't have to even be aware of it yet. Hopefully. Okay. Run. And then we go back to test app. We set up networking. It's like this. There we go. And then we zig build and run our app and see what happens. Seems mostly fine, to be honest. Error add FB actually is not happy. But we did get a pitch of 496 and a size of 3145728, which is probably the right size. This over 496 is 768. Yep, so that's right. But our add FB is not happy. Not happy. Okay. So why not? Do we get any logs here? Not really. I guess maybe we should log something on our side. So DRM octal add FB we are looking for driver mode set. I guess it'd be nice to know like why we failed here. So can we look up if libdrm, does he return like error codes from these? He must, right? So can we say like var ret is equal to 0, ret is equal to this. If ret is not equal to 0, so debug print add FB returned a number of ret. Okay, so it returned negative 22, which I think is enval. Yeah. Yep. Okay, so we are returning enval, and is that from us? That's also not clear. Right, so if we didn't correctly register ourselves, then that could be the case. Could be the case. So when we try to create our buffer, we have, oh, sorry, this is create frame buffer. I want dump create. We do create a handle and then try to return that handle. So it feels like it should be fine. We attach it to the file. Okay. So here, let's do a little log. Failed to find object. And here, maybe we will even write frame buffer init failed. And those are our two error cases. So let's see if we end up in those situations. And while we're here, we might as well check if this function is called at all. So we'll say sphero frame buffer create, just to see while we're here. We might as well. We might as well. Do you need to register the handle, or is create enough? Yeah, that's a good question. I thought the create was enough, but could be not. I mean, in the vert.io example driver that we're looking at, it seemed like they just created it. I think we can go back and double check in a minute. We can double check in a minute. But let's just wait and see what happens first. All right, run. And then we run root and test app. And do we see anything on our side, dmessage here? It doesn't even look like it's called, huh? I don't see our logs here at all, which is a little concerning. So maybe there's some sort of like kind of DRM debug KMS. What does it say? If DRM question mark, we log this thing, and then is this like if DRM debug enabled? Can we enable this shit? So each DRM star debug macro call site gets a descriptor, and only call sites are reachable. So how do we turn this shit on again? It's like it's in like. Oh, but we are not using this. So it's just calling enabled raw, which is an exported symbol. Oh, and then they have a module param named DRM debug. So we go into sys module DRM parameters, and then echo 1 to debug, and then run test app. Doesn't really. Oh. I guess we just want like. Can we just like do this? Oh, that seems right. I still don't really see any. Oh, here we go. Here we go. Oh, this is kind of cool. This is kind of cool. This would have been nice before. Bad frame buffer width should be greater than or equal to 0 and less than or equal to 0. So I suspect that we've actually seen and ignored this. So I think we saw in vert IO GPU derv. Maybe it was in like display actually. I think we saw something along the lines of like max res here. Right? So they had their minimum set to 32 and 8192. So I guess we will just kind of do something similar here. So where do we set our mode config? Here. So let's do vf this s drm dev this. Okay. And then we will set 32, 32, 1024, 1024 as well or something. I don't know. Dude, this K key has fallen off like 40 times. It's like not hooking anymore. It's kind of funny. There we go. So that should do it. At least it should fix that one particular error. Who knows if it fixes all the other errors, but it at least fixes that one. GPU will not support 8K, 144 hertz? Yeah, I guess not. I guess not. Oh boy. Oh boy. I think that we're actually like getting farther faster than I thought, but unfortunately I'm short on time today. So I would have liked, if I had like infinite time, I would probably just like push and try to get all the way to like an image printing on the other side. But I think we're probably going to get to the point where from like the user space perspective, this works. And then we'll have to save like actual writing of the image for something tomorrow, I think. But we'll see. So it is 3:40 already, which is unfortunate. Time flies when you're having fun. Sag. Dude, what is it doing? He's just linking, you know? Classic LD shenanigans. LTO isn't even on. This is just like no LTO. I guess we're quite close. Just need mmap and vsync on the driver's side. Yeah, I think I'm worried a little bit about like the communication scheme between the host and the guest. A little bit. But yeah, I don't think we're super far. Dude. all right, there we go. Run. And root test app. Ooh, that's kind of fun. Oh, okay. Wait, so that's fine actually. So, oh, maybe it's not. So we actually, the frame buffer creation worked, but then someone in here is mad about like an extra free on something, which is kind of surprising. Use after free on DRM release. So when we closed the app, he tried to release a handle that has already been released, which is probably a problem. Probably a problem. So I guess we have to be a little careful about this. So we have object put here. Object put here, which it seems like is correct. I think that like when we look up the object, we get a new handle to it, right? Maybe this doesn't. I assumed that this incremented the ref count, but maybe it doesn't. Display, vert, GPU display. So this is their frame buffer create. They do a lookup. Ah, and it looks like they transfer ownership of that thing to the frame buffer. So if frame buffer creation succeeds, then they don't free it. So it should actually be like this. Which means that this can be like this. Yeah, nice. Nice. That seems right to me. So we can try running this again. Except the build is going to take forever, so maybe we don't do that immediately. Fuck it. Fuck it. I think that like when it's hot cache, it's less of a problem. Hi, first time here. What language is that? C. We're writing C. We're in the Linux kernel right now. We are not really in control of language choice. We are just kind of using whatever exists. I guess we could have chosen to use Rust, like those other crazy GPU driver writer people, but, you know, we'd rather just do what is there. Sorry, I'm spamming the K key because it keeps falling off my keyboard. I'm trying to see if I can, like, push it in. So let's see if that fixes our double free issue here. There we go. So now it doesn't look like our kernel is mad at us, right? But we are mad at ourselves because we don't have any encoders. We don't have any encoders. So that's the next thing. So we have a frame buffer available to us, which is pretty cool. What do we even use the encoder for? Like, what is it even for? We get an encoder, just to map it to the CRTC, so that way we can call CRTC set to set it. Okay, cool. Sounds like you need an encoder. Yeah, we need an encoder. I've heard from somewhere. Maybe next time though. Do you think that if we ran it again, if it's not open, it's not worth it. I was gonna just hit like up enter a few more times, but it's gone. Okay, I think that we can probably swing getting the encoder ready. I think there's enough time for that. And then we'll try to call that our last target for the day, and then tomorrow we will come back and actually write out the image, which will be very exciting and very cool. Very cool. So just a reminder, where's our picture? Here's our pretty picture. So we have a connector, which indicates this port, who, you know, has like, has like modes associated with this guy, right? This guy has like 1024 by 768, 144 hertz. Then the encoder kind of says, how do we send a signal on this line? It's like, you know, presumably in my mental model, a piece of hardware that you configure. Now, in our case, since we are a virtual machine, that encoder should basically do nothing, right? We don't actually have any encoding to do. We just take the frame buffer and we just like slap it out there, man. So I imagine that's probably what the VirtIO GPU people did. I would imagine. So I think that everything was in virt GPU display, and everything was in mode set init. So they had output init, and in output init, I think they allocated an encoder in here. Yeah, and they just call simple encoder init with some encoder helper functions. So like, yeah, so they're just doing jack shit. They're just doing nothing. So that should be very easy for us. That should be very easy for us. Gajos Born, thank you for the prime. Much appreciated. Much appreciated. Now here, they also have to set the possible CRTCs, but what if we just didn't do that, right? Because we don't have a CRTC yet. We are eventually going to need one. Which I guess what do they do for their CRTCs? These are more interesting. They're kind of like configuration of this section. The CRTC kind of says like, oh, okay, so we're going to take a buffer and our buffer is like 380 by 240. So I'm going to like tell the encoder to like walk it at this speed. And then we're going to tell the monitor to like go into that mode. He's got like actual interesting behavior on him, probably. So this is all kind of generic, actually, surprisingly. Although here they have specific implementations for their driver. Okay, so yeah, we'll just call it. We'll call it on encoder today, and we'll come back for CRTC tomorrow. So in that case, dude, my K key fell off again, dude. I'm gonna lose my fucking mind. Did we ever call DRM connector register? That doesn't sound like something we did. Yeah, we didn't. So what does that do, and why is everything kind of working okay without it? Register connector. Register user space interfaces for a connector. Only call this for connectors which can be hot plugged after DRM dev register has been called already. So they're just fucking idiots, right? Well, I shouldn't say idiots, but like I think they're just not doing the right thing here. Because their DRM dev register happens after this. Right? This happens up here somewhere. Right? They call it here. So we just don't have to do that. Big Foe, thanks for the prime. Much appreciated. So yeah, we just don't have to do that. We don't have to do that. But we do have to hook up our encoder. So it's literally just this. And then our possible CRTCs will just be 0 instead. Now, our encoder needs to live in memory somewhere. So I guess in our version of the driver, we're just going to store that as like private driver data. Right, so we'll kind of do this down here, right behind the connector stuff. We'll also do encoders. This is going to be 0. And our encoder is actually going to be from priv encoder. In the same way that our connector lives in our driver data, so will our encoder. This guy needs to be included. So we will do that. And then he's mad because encoder doesn't exist, so we're gonna have to add that thing. DRM encoder is an encoder. Boom. Boom, boom, boom. All right, so now this is gonna be DRM dev here, and we have to implement our helper funcs. And then here this should be a dot here instead of an arrow, and now we have to implement this. And so I guess we'll copy paste the VirtIO version. Because it seemed simple. So this is just this, and then we go into their implementations, and these are just this, completely fucking empty, and then we just replace vert IO with Sphero, and then we should be chilling. Should be chilling. Make. By the way, it's supposed to be the big fox, but I typed it 12 years ago, and I'm like, oh, that's so funny. The big fox. I see. The X's on the edge, matching the X's at the beginning, really kind of undermine that request. Right? For just, we might as well, since we're just compiling anyways, for y'all on YouTube. The big fox really undermines what he wanted. I think it, do you embrace it at this point? Like if you're stuck, you're stuck now. You made a decision when you were a child and you're stuck. Do you embrace it and just say we are the big foe now? Or do you correct everyone for the rest of your life? Also, triple X at the end would have been a bit sketchy, especially for a 12-year-old. You don't want a 12-year-old having triple X at the end of their name. I actually wasn't allowed to watch that Vin Diesel movie just because of the name back in the day. I wish I had been, dude. Now I'll never see it, but man, that guy's so cool. In Fast and Furious, he's got like, his head is like made of like fucking metal. He slams his face and stuff all the time. It's totally fine. I'm sure in Triple X it was the same. That guy's crazy. XXX was peak Vin. If that's peak Vin, that's crazy. Like, okay, I watched a lot of Jason Statham movies. Like, if you're watching Triple X and you know that's peak Vin Diesel, I assume that you also have a peak Jason Statham movie in mind. Would you compare? Do you have? Could you give me an example that is like equivalent? Okay, let's run this. We all know it's the first Riddick. Oh, I haven't actually seen those either. He still says no encoder, which is kind of surprising. Very surprising. It's interesting, a lot of people actually pronounce it the big fox, even though the big foe is more accurate with spelling. Oh, wait, crazy. They're smarter than me. Okay, so this is surprising. So can we look at our mode res? He does say that he has an encoder here, right? He does think that he has an encoder, but when we try to get the encoder from the connector, we try to tie those things back together, he's not aware, which means that we probably just forgot the important part here of tying the encoder to the connector, which we saw in vert GPU display. We did see that here. It was like encoder here. Connect, attach encoder. So this encoder is attached to this connector. We just forgot to do that. So let's get some ampersands on here and try again. Try it again, baby. But yeah, maybe I should go back and watch more shitty Vin Diesel movies. Because, like, I know this is like one of the worst takes ever, but I stand by it, and I will stand by it forever, that Fast and Furious 7 is like the best movie I've ever watched. It's just so funny. It's got all three of my favorite bald actors in it. It's just like, what a banger. And it's like, maybe I should go back. Maybe I should. Okay. Run. This is the problem with long compile times, is like, now I just have to talk about Fast and Furious. And it's like, this is a programming channel, sir. Nobody gives a shit. Nobody cares. So it's still actually no good, surprisingly. So we might have to poke and prod this a little bit more closely. So I guess what is our code actually trying to do? That's a good question. So in here, when we try to get an encoder, we actually just try to get, we actually call get encoder here. So is our encoder ID valid here? In our connector, we have encoder ID 0, which is really hard to tell if that's valid or not. Right, because encoder ID 0 might be completely fucking useless. right? It's really hard. Really, like that could be the same as it being nulled out. So can we go in here and just see, like when we call this, he does add possible encoders in here. Which, oh, here we go. We get count encoders 1 attached to our connector, as well as the encoders associated with it. So it should be fine. Unless it's not. So what is our encoder ID? Do we have that information somewhere? I guess we don't because we can't call get encoders. Encoder helper add. I guess we never set this encoder ID. Right, this never gets set by us, which I assume is where this comes from. But this is called on DRM encoder init. So they call this with the mode config num encoders. Okay, so that's probably fine. Where do we set our mode config? Here. So when we call encoder init, they must take the mode config from our device and use that as an input here. Where? Yeah, it must be in here somewhere. Where did we see that again? It was here. So this was on DRM encoder init. Which oh yeah, this comes from the dev. Yeah. Okay. We're chilling. Maybe you actually need to register like that comment says you don't need. Yeah, it's very possible. Very possible. Oh, but I think what's kind of more likely to me is that the call to get encoder ID is just not implemented somewhere. Right? That's kind of more my suspicion. Fuck. 3:57. Okay, I'm gonna look for 3 more minutes and then we call it. So there's encoder, get encoder. We would have to look here. So encoder find is going to look for these IDs. So I think that, is there anything in here that's like, that has like driver specific implementation here? We should probably log what the failure is in the same way that we did for add FB. We can look at this and we can say, oh, we can't, so here he's gonna return an optional pointer. And does libdrm have like libdrm? Does he return errors properly here? Get encoder. Get, oh, it's get encoder. There we go. This does not help us at all. We could look at xf86 DRM mode C and look for get encoder. And does he return anything interesting here? He just returns 0. So we just lose, we completely lose the ioctl failure, which is annoying. So we'll have to log it on the kernel side. But unfortunately, we have to call it here because I'm short on time today. I would love to keep going. I'm having a bunch of fun. But, you know, sometimes you have to call it. So thank you for watching, guys. I think we made good progress today. We got through connectors, buffer allocation, frame buffer allocation. And so I think we're almost there. We just have to do encoder, CRTC, And then once we have that, we should be like in a state where everything like works, but nothing happens. And so we'll kind of move on from there and try to actually figure out how do we like DMA copy stuff from the guest into the host. And so that will be a problem for Tuesday, not tomorrow. I'm going to take tomorrow off, and we'll be back. We'll be back on Tuesday. So tune in then if you want to see it, or if you're watching on Twitch. These things will end up on YouTube under the playlist. Underneath the playlist, demystifying Linux graphics stack. So if you want to check that out, you can subscribe to the YouTube and see when that comes up. The code here will eventually end up under GPU testing env. Probably not until like this feature is complete. But it will eventually end up there. If you're watching on YouTube, there's a Twitch link in the YouTube description. We stream most days from 12:30 to 4 o'clock Pacific time. 12:30 to 2 gets archived in member streams or Patreon. So those are kind of like, we try not to do like major feature development, but we might do like reading or bug fixing or minor features, right? So but we try not to make like major progress. Like today we were reading a lot about like, the 12:32 segment was reading about GEM and like some of the like, we've been kind of like implementing a lot of stuff here without fully understanding it. So we were kind of taking a peek at like, what do all these things mean, right? And like how does the memory management system here actually work, like so that we could like have a starting point when we started writing today in the mainstream. So if you want to see that, those are available. Otherwise, I think that's it. Like, subscribe, Twitch Prime, and yeah, YouTube goodbye. Twitch, let's find someone to raid.